Hi, my name is Kashif Imran, and I'm a senior solutions architect in AWS AI. I work with large number of AWS customers who are looking to take advantage of machine learning to advance their cloud journey to the next level. Today's webinar is about extracting text and data from any document with no prior machine learning experience. Let's quickly look at the agenda. So we will start with some context about document processing, why documents are still important today, and how they are processed, and what kind of challenges organizations face today when they are processing documents. We will then look at Amazon Textract and how it makes processing documents at scale with high accuracy with very easy to use simple APIs. We will have an overview of the product, we'll look at core features, we will go through the APIs, and explore those APIs using some demos. We will then talk about some of the use cases and some reference architectures, and then wrap up with some information on how you can get started with the service. Let's talk about why documents are still important today. As we talk to many customers, they tell us one of the problems they want us to solve from the computer vision standpoint is the ability to process documents at scale. Because documents are still a primary tool for record keeping, communication, and collaboration across a wide variety of businesses, whether it's finance, insurance, legal, medical, and so on. A lot of information is locked up in unstructured content, whether it's paper or, for example, scanned versions of papers and so on. Let's look at an example of a document. Here is our typical mortgage application form that many of you have filled when you purchase a home. Just alone in 2016, 16.3 million of these applications were processed, generating a business of over $2 trillion. Here is another example of a document which many of us very familiar with, and with this year's tax season, I'm sure many of you are looking at this. Just alone in 2018, IRS expected that over 240 million of W-2 tax forms will be processed. Why do we need to process these documents? What makes it important is if you have digitized versions of these documents, it makes it very easy, for example, for search and discovery. You can quickly search and based on some query, get a bunch of relevant documents back instead of going through a huge stack of this unstructured content if you don't have, for example, it indexed and make it available for search and discovery. Similarly, compliance and control is a very important aspect, like in enterprise and many industries where you have to follow some regulatory compliance and so on. If you have digitized versions of these documents where you have extracted text, it makes it a lot more easier to comply with those rules. Another important aspect is business process automation. So a lot of these business processes, as documents come in based on the text and data, and a lot of that is unstructured data, which then might require to kick off other business workflows. It can easily be automated if you have digitized versions of these documents instead of just paper-based documents or scanned versions of those. Let's see how people have kind of figured out how do they process these documents today. So some of the mechanisms today are, for example, where they are just using humans and doing manual processing. And I'll talk about some of the challenges there. Other folks are using some of the traditional optical character recognition, like OCR, and use those to get some text out of documents. And then people have figured out to use some rules and template-based approach to extract some of these text from some of these documents. Let's look at challenges that you usually run into, especially when you try to automate some of this at scale. When you do manual processing, it can be expensive, it can be error-prone, and time-consuming. Let's look at just one example to give you some more idea. So here is an example of a form. Look at this field. If you give this to 4 different people, you might get 4 different outputs. So for example, whether exempt is true, or CPP/QPP is true, or 28 is true, or RPC is true. So when humans are processing these documents manually, you might get variable output and inconsistent results, and you might need multiple human reviews for consensus and so on. Similarly, when you use a typical OCR-based approach to get text from these documents, it can be challenges for a wide variety of documents. For example, when you have documents with multiple columns. So here is a very simple document with 2 columns. If you extract that using a traditional OCR solution, you get an output like this, where text from the first column can get appended with the second one and really give you something which is not very meaningful. So traditional OCR solutions usually don't get multi-column detection. And if you have text, for example, rotated text, or if you have stylized fonts, the accuracy drops and it doesn't necessarily get detected in many of those solutions. Here is another example of a document. A lot of documents usually contains, for example, tables. And if you process this table with our typical OCR solution, you can get an output like this. Some people might, have figured out that, okay, maybe I can use spacing, for example, and then kind of do some templating on top of it to extract this. But you can imagine it can become very tricky, especially when you have different types of documents containing different types of tables with different sizes of rows and columns and so on. OCR, reads from left to right, ignoring the table structure, and makes it very difficult to extract tables in a meaningful way, and then being able to automate that process. Another approach where people have kind of figured out using some rule and template-based approach. Again, these are limited by the accuracy of OCR itself, and then usually require significant development and management overhead. And then you have to create lots and lots of templates, and templates are brittle. Let's look at an example for you to get some more idea. So this is a well-known W-2 US tax form, and all of these forms have the same information, but for even in case of W-2, there has hundreds of variants each year. Same information, just laid out differently. So if you are trying to use a rule and template-based approach, you have to create templates for all of these versions, and it can become a nightmare pretty quickly if you have a wide variety of forms that you're trying to automate. Looking at from the computer vision, so if you look at some of these forms, just to give you some idea why this is a challenging problem, as humans, we can see most of these forms look pretty similar. But if you look at the RGB channel information, for example, below, you see computers see all of these forms very differently. They don't see any similarity in any of these forms, even though some of these look pretty similar to a human eye. And that's what makes it complicated and challenging problem. And this is where Amazon Textract comes in. So we announced Amazon Textract at AWS reInvent, where Textract is a deep learning based service which can easily extract text and data from virtually any document. So let's look at some of the core features of Amazon Textract. Textract can help you extract text, and we'll talk about each of these features in detail in a second. But text extraction is like OCR++, where it gives you the text, but you will see it gives you a lot more information about the geometry of that text. So you can use that information to process the document in a lot more meaningful fashion. It helps you extract tables, so you get information about rows and cells, and then you can use those, for example, to do different arithmetic operations on the values in the cell, etc. Amazon Textract allows you to extract forms and gives you key value pairs. So in case of forms, for example, you can easily then get values like first name, last name, and so on. And most importantly, to be able to take advantage of all of these features, you don't necessarily need to have any machine learning experience. We provide you very simple to use API for each one of these features that we will explore in next couple of minutes. And we provide a couple of SDKs as well in a variety of languages. So you can just take advantage of those, just call these APIs, get the results, and automate document processing without having to learn about machine learning. So let's dig into each one of these features, and we'll go through the APIs and how you can take advantage of these. So let's first look at text extraction in Amazon Textract. So the text extraction feature, in this case, when you send a document to Textract, it returns you text with information about, for example, words, lines, and page, and so on. So you get a couple of blocks back where each block has a type about like word, line, and page, and so on that you can use to process that document. The API that you use to extract text is called DetectDocumentText. In this case, the document can be just a blob, raw bytes that you can send to the API, or it can be a document sitting in Amazon S3, for example. The response of the API is a list of blocks, where each block has a type, like its page, a line, or word, and so on. It has an ID, and then it has some relationships about other blocks within the document. This is the JSON view of the same API request and response. So again, you can see this is where you can send the raw bytes or S3 object, and then response return you a list of blocks with information about where these blocks are in the document and so on. So what this makes it easier is to process, for example, documents with multiple columns. So in this case, if you use Amazon Textract to get text from this document, your output is going to look like this with appropriate reading order. And you don't have to maintain different templates and so on to be able to get text from these multi-column documents, etc. Let's look at a demo. So let's start with looking at an example document here. So I have a simple document here that you can see, which doesn't necessarily have very good resolution. And that's the point I want to show here, how you can still get very good accuracy with Amazon Textract. So in this case, we have a relatively simple document. Let's see how we can call DetectText to extract text from this document. So I'm here in my on my CLI. Let me let's run this command here. So I'm just going to call DetectText, a Python simple program, which is then going to call Amazon Textract with this image and get the result back, parse the blocks, and show you the output. So you can see in this case, we were able to get text from this image by just calling a simple API. Let me open the program here so you could see how we are calling. All right, let me just bring that to the view. All right, so here is a very simple program that you can see. All we're doing is with few lines of code where we just initialize the Textract client. Then we call DetectDocumentText, passing in the file name. In this case, I have that document already sitting in my S3 bucket. We get a response back with blocks, and then we just iterate over those blocks and then print them on the screen. Now let's see another document where here it's our 2-column document. So let me just close this one. Here we have multiple documents. Let's see if we call Textract with the same document, what kind of output we get. So let me first use the same program, and we called it on a 2-column. So you can see, even though it returned us different blocks with the geometry information, we didn't take advantage of that. So in this case, we didn't necessarily get the reading order correct. But now let's go ahead and take advantage of the reading order. And run this. In this case, now you can see, let me minimize this so we could see it side by side. So you can see now we extracted the text in the proper reading order. Let me show you pretty quickly how we are able to do that. So you can see, again, it's a very simple app. Again, we initialize a Textract client, call the DetectDocumentText API, get the response back, and then we're just iterating over blocks, looking at the type of the block, and then doing some math by using the geometry information that it returned us, including the bounding box information where each of the block is, and then just printing each one of those lines. So by taking advantage of the additional information that Amazon Textract give you, even with traditional OCR, you're able to process documents like multiple columns and so on. Now let's look at another example. So as you extract some of this text from Amazon Textract, how can you maybe then use some of the other AWS services? So in this case, let's call, for example, comprehend and pass it the text we extracted to get sentiment analysis. And later in the presentation, I'll show you how our typical production architecture would look like. In this case, we'll just call Amazon Textract, get the text back, and then call comprehend to get the sentiment analysis. So as I run this, in this case, we got the sentiment back as neutral. Let's go ahead and see how this one works. So again, you can see with only few lines of code, we initialize the Textract client, we initialize the comprehend client, we called DetectDocumentText, get the response back. Then for each block, we concatenate the text and then send that text to the comprehend, and then we just print the sentiment. Now let's go ahead and look at another example where we can use Amazon Translate, for example, to basically get this text translated. So we run this. Again, in this case, you see each line that we extracted using Amazon Textract, and then we call Amazon Translate to get that translated into a different language. Let's look at that one and see how easy it is to build something like this. Again, you see very simple program. We initialize the clients, call DetectDocumentText, get the text back, and then simply iterate over each line. And for each line, we are calling Amazon Translate, get the result, and then just simply print it. So I hope that helps you understand to see how easy it is to take advantage of Amazon Textract APIs to extract text, and then take advantage of the additional information, including bounding box and geometry information that you get for each word, line, and pages to then process different types of documents, including the ones with multiple columns and so on. Let's now continue with the other features of Textract. So now let's talk about table extraction. Amazon Textract lets you extract tables from documents. So in this case, when you send a document, the response gives you blocks of different types. In this case, pages, table, and cell. And for each block, you get text along with the confidence score and the block relationships. For example, cells within a table and so on. So again, the API for this one is called Analyze Document. And you simply pass in the parameters as feature type tables. So in this case, again, a document can be either raw bytes, a blob that you send, or it can be a document sitting in an Amazon S3. And you return the blocks. The response is a list of blocks. Each one has an ID and a relationship with the other blocks in the document. Here is the JSON view. Similar to previous example, where you just set a request with some parameters to whether your object is in Amazon S3 or raw bytes, and set the feature type, and you get a response with a list of blocks, each with their types related to, in this case, in the context of table, things like cells and rows and so on. So how does Textract make it simplify to extract tables. So if you look at an example like this, and we saw earlier how traditional OCR would just give you rows of text. In case of Amazon Textract, it recognizes the table, it grouped those words by cell, and give you an output like this. So you'll easily see things like a column where you have start date, end date, and you'll see the values for those. So very easy to process tables, automate the process, and do it at scale. Now let's switch to a demo and see how table extraction work with Amazon Textract. So let me first switch to my console, and let's click on Try Amazon Textract. So here you see an example document where it has it's a typical employment application form with a table at the bottom. So let's go ahead and click on the Tables tab. In the raw text, you just see the traditional bag of words where it's just showing you all the text that it's seeing. But when we go to Table, you can see Amazon Textract is able to detect the table, and then we were able to show all the columns and all the rows along with all the words that's part of that. Let's switch to a program here. Let me show you how you can take advantage of the API and build something like this. So let's go to Analyze Document Table. So in this case, let me first show you the form document that we're going to process. Here I have the same image that you just saw in the console. So we're going to use this by calling the API and see what kind of results we get back. So let me run this. So see, in this case, we called the API, got the results back, and generated this output where you can see, we're able to detect each rows and columns and so on. Let me open this and show you how we're doing this behind the scene by calling the API. So again, in this case, the program starts by taking the input file. It simply calls Amazon Textract to get the results back. There is just simple code to initialize the client, get the result back, extract all the blocks, and then it just take advantage of the different block types. For example, things about information about cells and rows, row index and column index and so on, and then just format those blocks to show you how the table looks like. Let's look at another example where a lot of times there are use cases where maybe you want to extract this table, but maybe export is as a CSV or something. So let's see if we run a different program. In this case, it generated the output as output.csv. So let me just open this. All right. So you can see in this case, because we extracted the exact information, and let me open the document so we could see it side by side. So in this case, you can see we got the values like columns like start date, end date, employee name, and so on, and we're able to reconstruct the table. All right, great. With that, let's look at the next feature, which is form extraction. So Amazon Textract allows you to send a document where it can detect forms. So it can return you form field names in the form of key and associated value. It returns you along with that confidence score and things like page number and the relationships between different blocks, for example. So the API for form detection is the same API, analyze document. In this case, you simply pass the feature type as forms, and you get a response back with the list of blocks where each block has an ID. It can have a type like page and then key value, as well as relationship with the other blocks on the page. Here is the JSON view for that request and response. So again, in this case, we're just sending either as raw bytes or an Amazon S3 object, and then setting the feature type to form, and you get a list of blocks back with geometry information, things like bounding box and so on, as well as information about form. So Amazon Textract makes it simple to process forms. So for example, in this case, if you have a form like this and you send it to Amazon Textract, you get the logical grouping gets captured. We're able to capture the relationships, and glyphs are captured. So it's a lot more easier to then process the information. So you can see things like first name and last name and so on, and then easily process them in your business process workflow. Let's look at a quick demo and see how form extraction work in Amazon Textract. So we'll use the same example. Let's actually first go to the console. We'll look at the same example. So here we have an employment application. For the same one, let's see how when we go to the form, you can see it's able to detect things like full name, phone number, home address, and so on. And then because we are giving you the geometry information of all of these key values, it's able to then draw a bounding box and so on. Let's also look at from the API perspective how we call that. So let me just clear this and go to forms. So let's see an example here. We have a simple form parser, which is going to look at this document, extract different key values, and it's just then printed all the key values it found. And then, it can ask, tell me, if you want to search for a specific value. Yes, I can just say, okay, tell me what is the value of full name in this document, or what is the value of phone number in this document, and so on. So very simply, you can take advantage of the Amazon Textract API to process forms, extract those key values, which then can be used to kick off other workflows, stored in data stores like DynamoDB for fast lookups, or can be stored in things like Elasticsearch to enable indexing and searching and those kind of use cases. Let's have a quick look at the form parser. So you can see, again, this is a relatively simple program. You, again, initialize a client, get the text back using the Analyze Document API, and in this case, passing the feature type as forms. We get the list of blocks back, and then it's just a matter of processing those blocks based on their type. In this case, using the key value set, and then just processing those. And rest of the program is just about asking which value you want to search for, and then look for the dictionary and print those values that we extracted using Amazon Textract. All right, with that, let's move on. Cool. So we looked at different APIs, including DetectText and Analyze Document for text extraction, table extraction, and form extraction. So Amazon Textract support both synchronous and asynchronous APIs. For synchronous APIs, these are where you have low latency use cases where you have a single page document. For example, maybe you're taking a mobile capture. So you directly call Amazon Textract, get the JSON back. You can process it to then pre-populate the form, for example, and get the results and process them. Then when you have multi-page documents where maybe you have hundreds or thousands of pages, you can use asynchronous API where you can call Amazon Textract. It can start a job to process the document. When the job is complete, it notifies you, and then you can get the results and process them and store them in whichever data store, for example, that you're using. So this is how the asynchronous API workflow work. For either one of these, whether you are detecting text or you are analyzing document for form or table extraction, you can start the job by calling either start document text detection or start document analysis. And the request, as you can see in the JSON, where you send the document can be in S3 bucket. And you send some additional information about the SNS topic through which you want to get notified. And what you get back is a job ID. Now, to get the results back, you can simply call the get document text detection or get document analysis, send the job ID, and then you get back a list of blocks, again with different types of these blocks depending on the APIs you use, as well as all the geometry information, things like bounding box and so on, and relationship with other blocks in the page. In addition to calling APIs or using AWS console, you can also use AWS CLI to quickly call Amazon Textract and extract text, for example. So here is some API reference for AWS CLI. For each one of these APIs, you can just quickly go to CLI, type this command, and get the document analysis done for both synchronous as well as asynchronous version of the APIs. Now let's look at under the hood how Amazon Textract is able to process some of the documents which maybe some of the traditional OCR solutions not necessarily give you high quality. So think looking at some of these examples of documents, for example, when there is orientation, because Amazon Textract is a deep learning based service. Orientation and some of these things which can be challenging for many other solutions, Amazon Textract is able to give you much higher accuracy because we are able to detect different orientations and without you having to worry about this, still give you high accuracy results with high accuracy. Similarly, structure variability. So if you have different forms where maybe things change a little bit, it's not going to break just because one of these fields, changed by a few centimeters or something. And because we are template agnostic, Amazon Textract is going to automatically still continue to work even when some of the structure of these documents change without having you to tell us about the structure of these documents. Similarly, you can have a variety of different documents, and based on the different deep learning techniques, Amazon Textract is going to know about these different documents without you having to define templates, etc., for these documents. There can be many documents, as we understand. These are scanned, or maybe use like phones and some of the other techniques to capture these documents. So you could get this photometric effect here, for example. But in this case, again, Amazon Textract is able to take advantage of different techniques, things like we're going to do segmentation and rectification to make sure that we can still detect text with high accuracy in these documents. Similarly, many documents like receipts or invoices, for example, there could be, it's hard to get those with perfect geometry. And again, Amazon Textract in this case is going to be able to take advantage of things like segmentation rectification to give you the high accuracy results and still detect those. Again, understanding the document structure and the context to find table. So in this case, we're able to detect a table when there is good boundaries and so on, or even understand cells, for example, when there are no explicit boundaries there. So we're able to take advantage of different deep learning techniques to still extract those. You could have tables, for example, with variable size rows or columns. Again, it's Amazon Textract is going to be able to handle these kind of variations. Things like detecting phrases or groups of words. So forms like these, where you have full name, John, where there is first name, middle name, and last name. Amazon Textract is going to be able to extract these as key value for easy consumption here. Similarly, going beyond traditional OCR, where we are able to infer the key value association, so detecting the structure of the same document without template. So as I mentioned earlier, there could be hundreds of variations of W2 form, for example. Again, you don't have to define different templates, and Textract is still able to extract those key values for you. Similarly, there are use cases where maybe you have a form like this, where, for example, the key is above the name, whereas in another instance, the key is below the name. And you can expect Amazon Textract to detect that automatically without you having to define any templates or any of that. There are use cases where maybe some of the values could be empty. So for example, in this case, the middle name is empty. So instead of you having to then manually review those or some of those things, Amazon Textract can infer those empty values. And for example, in this case, can return null for middle name here. Make it a lot more easier to automate and process these documents at scale. Now let's look at some of the reference architectures. So I showed you some of the examples earlier when we ran some Python code, for example, to call Textract and then a couple of other AWS services. So this is how you can build a traditional where you want to index large number of documents, and then you can search those. So a traditional workflow will look like where you bring in those documents to something like Amazon S3 bucket, which can then trigger a Lambda function. Lambda can then call Amazon Textract, get all the text back, including, for example, things like tables and forms. And then based on all the data you get back, you can then store it in something like Elasticsearch and then consume it, using different tools. Similarly, for NLP use cases where you want to do natural language processing, and we saw some of these examples earlier in the presentation where we called like comprehend as well as Amazon Translate. So in this case, your documents could come to S3, which can again trigger a Lambda function. Lambda can then call Textract to get the text out of the document. And then it can call languages like comprehend, Amazon Translate, or comprehend medical, for example, for medical analysis. And then all that extracted data and analyzed then can be stored in services like Elasticsearch, and then it can be consumed to discover insights, for example, in this case using medical documents to improve patient care, and for a wide variety of other document types and so on. Another example is where you could be taking, for example, form capture using a mobile document, using a mobile app. So in this case, an end user takes a picture using their mobile phone. It can then call Amazon Textract, get the results back, and pre-populate the form on the end user screen, which the person can then review, confirm, submit, and then it can be stored in some sort of data store and then processed depending on the business workflow needs. Some of the launch customers we had when we launched Amazon Textract were Roche, Alfresco, and Cox Automotive. And we have some details about their use case on Amazon Textract website where you can find more details. To wrap up, some of the benefits of Amazon Textract is where you are able to extract data quickly and accurately. It eliminates the need of manual processing, which really allows you to lower the cost of document processing. And most importantly, from the development perspective, you do not need any machine learning experience. Just by taking advantage of very simple to use APIs, in addition, as we provide different SDKs, it makes it further easier to call those APIs. You're quickly able to build pretty powerful solutions and automate document processing at a much higher scale. Amazon Textract has tiered pricing. And in addition, as you expect, like other AWS services, has a free tier as well, where you can take advantage of up to 1,000 pages or images for text detection and up to 100 pages or images for table or form detection. During launch, Textract is available in these 4 regions, in Ireland, in Ohio, in Virginia, and Oregon. To get started, here's a link that you can go to, sign up for preview, or you can learn more about the service. Thank you.